Alright, these are our notes for section 10.3 over the properties of logs. What we're going to look at in this pencast are the 4 different properties of logs, and then we're going to do 4 examples. Now the examples don't go with each property. The properties are all going to be in your problems together, and you'll have to figure out which properties you are using for each problem. So again, they're not going to be one example of each. They're going to be all combined. The first property we're going to look at is called the property of equality. Now, we've used this before. The property of equality is when we have a log with the same base on both sides. So suppose we have log base 8 of 6a equal to log base 8 of 36. What this property says, and we use this back in 10.2, is that if the logs have the same base on both sides, we can just cancel them out. So we get 6a equals 36, and we can solve from there. So it allows you to cancel logs with the same base from both sides. Now, not only does it allow you to cancel them, but you could add them if you wanted. So suppose we had a problem like this. 5 to the x power equals 36. What this says is that we could add a log to both sides. So suppose we say log base 10 of 5 to the x equals log base 10 of 36. Now this idea here, adding to both sides, is something we'll use in 10.4. So you won't be using that idea today, but you can. And I want you to know that the property of equality allows you to take the logs away from both sides, but at the same time it allows you to add logs to both sides as long as they have the same base. Now there's one other thing you need to remember, and it's that there must be one and only one log on each side. Alright? You can only have one log on each side of the equal sign. If there are more than one, and this is a common mistake, you're going to have to use the rest of your properties to combine them. You have to get down to one log on both sides. So if there's more than one, suppose you had something like this, log base 5 of 2 plus log base 5 of a equals log base 5 of 6. We can't cancel. Right, doesn't work here, and this is a common mistake because there's not one log on both sides. The left side has 2 and the right side only has 1, so we can't cancel. It only works in cases where there's one log on both sides or we're adding one log to both sides. Okay, that's the property of equality. The next one is called the power property. The power property, and I'm going to use several letters here, don't get confused by the letters, we're going to have a bunch of variables. It says if we have something like log base b of m to the p power, it's going to become p times the log base b of m. So what happens is that the exponent moves out front. Now here's an example with numbers. Suppose we had log base 5 of a to the 7th power. It would become 7 times the log base 5 of a. What happens is that that exponent moves out into front. And that's the power property. Now, it goes the other way also. If I had, and you'll be using this today in the second case, not necessarily moving an exponent out front, you will have something like this. 6 times the log base 8 of 4. And what you're going to want to do is take that out in front and move it up to the exponent so that it becomes log base 8 of 4 to the 6th. This is what you'll be using today. But that's the power property. It allows you to move an exponent or a power up from the top to out in front, or from out in front up to the exponent place. The next one we're going to look at is called the product property. Now the product property is a little tricky. It goes with addition. So suppose we had something like log base b of m plus log base b of n. What happens is that when they're being added together, it's going to become log base b, notice that we had the same bases on both, of m times n. We multiply them together, which is where we get the name product from. Alright? So here's an example with numbers. Suppose we have log base 7 of 2a plus log base 7 of 4. What can happen, since they both have bases of 7 and they're being added together, we can say it becomes log base 7 of 4 times 2a. Or 2a times 4, it's the same thing. And that will equal log base 7 of 8a. And that's the product property. Now, it does allow you to pull them apart. We're not going to really focus on that. I could pull 8a apart and make it log base 7 of 8 plus log base 7 of a. That's pulling it apart. But really, we're going to focus on putting the two logs together with a plus sign in the middle. Okay? That's what we're looking at. If they have the same base, they're being added together, two separate logs, then we can take them and we can multiply what we're taking the logs of together, and it becomes a new expression. The last thing we're going to look at is called the quotient property. It's really similar to the product property, except quotient goes with division and product goes with multiplication. Now we focus with addition in the product property, so we're going to use subtraction for the quotient property. Log base b of m minus log base b of n. Notice again, same basis. Subtraction this time, though, it's going to become log base b of m divided by n. Okay, we use division. Now here's an example with numbers. Let's say we have log base 2 of 6a minus log base 2 of 4a. Okay, same basis, subtraction. So what happens is that it's going to become log base 2 of 6a over 4a. And it's always the first one over the second. So 6a is going to become our numerator, 4a becomes our denominator. And then we could simplify that. Log base 2. The a's are going to cancel themselves out, and 6 over 4 is really 3/2. So there would be our answer. Log base 2 of 3 over 2. And that's okay. Now those are your four properties. You have the property of equality, the power property, the product property, and the quotient property. And it's really important that you understand all four of those, because what's going to happen is you're going to have an example and you're going to have to solve for a variable. And then you're going to use these four properties to simplify your expressions to get down to one log on both sides. And when you have one log on both sides, then you can use the property of equality. Now, there's a certain order we need to check when we're combining logs and we're doing these examples. And the first thing we should always check for is the power property. We didn't go over them in the same order that we need to check them in. Okay, so the first one we should check for is the power property. Second one, and these kind of go together, and you may have both in the same problem, but the product and the quotient property. Usually it'll be one or the other. You're going to multiply them together or you're going to divide them. So it'll be one or the other, but they should be the second thing you check. And then the last thing, by the time you've gone through those three properties, you should be ready to use the property of equality, where we will cancel out the logs on both sides. And then we just have an algebraic equation to solve. So let's look at our four examples here. The first one we've got is log base 4 of a plus log base 4 of 9 equals log base 4 of 27. Notice that there's not one log on both sides. So we can't just cancel them out. We can only cancel them out when there's one log on both sides. And the left-hand side has two logs. So we're going to go through our properties. We're going to start with the power property. Check and see if we have any numbers out in front of our logs that we could move up to an exponent. Well, that first term there's nothing out in front. Second term, there's nothing. There's really a 1, but there's no coefficient written there, no 3 or negative or anything that we could use. And then the last one, there's nothing. So the power property is done. We can't use that. Now we're going to look at the sign between them, and it's a plus sign. Plus means that we're going to use the product property. All right? Product property means we're going to multiply what we're taking the logs of together. So it's going to become log base 4 of a times 9 equals log base 4 of 27. The right-hand side doesn't change. Now, a times 9 is really 9a. So we're going to rewrite it. Log base 4 of 9a equals log base 4 of 27. Next thing we look at, see if we could use the quotient property. Well, we don't have any subtraction, so no, we can't use the quotient property. And like I said, it'll be one or the other usually, product or quotient. We already used product, so we're probably not going to use quotient. And now we're going to use product or the equality property. Equality says as long as they have the same base on both sides, and these do, log base 4, we can cancel them out, and we have 9a equals 27. Now it's an algebra problem. Divide both sides by 9. A equals 27 divided by 9 is 3. There would be our answer. Now, I've boxed it, but before we box it, we should always check, especially on these types of problems, because remember, you can't take the log of a negative. Your b has to be greater than 0. And your b is what you're taking the log of. Okay? So we're going to go back to the original problem, and if we plugged a 3 in for a, then we would have log base 4 of 3, and that works. It does check out because it would be positive. We're taking the log of a positive number. So this is the answer to the problem. Now, do I expect to see a check step? Not usually. You can probably check it in your head and think it through, but you do need to check because some of the answers won't work. Okay, so there's one example. Let's go on to our next example. Log base 7 of 24 minus log base 7 of y plus 5 equals log base 7 of 8. First thing we want to do is check that power property. Are there any numbers out in front of our logs that we could move up as exponents? No, there's not. So we're not going to use the power property on this one. Step 2 is to check for the product or the quotient property. Well, the sign here in the middle is a minus sign, which tells us it's going to be the quotient property. Quotient means we're going to use division, so we're going to rewrite it. Log base 7 of, first thing becomes the numerator, 24 over y plus 5. The whole thing, because the whole thing is in parentheses, equals log base 7 of 8. We've used the quotient property because there was a minus sign. Now we've got the same log on both sides, log with the base of 7. Equality property says we can just cancel them out, and we get 24 over y plus 5 equals 8. And now we're going to solve it. To solve this one, we want to get rid of the fraction here on the left. So we're going to multiply both sides by y plus 5. That will cancel those out, and we have 24 equals 8 times y plus 5. Now at this point you could do one of two things. You could distribute your 8 through, and then subtract and then divide by 8. That works. You're going to get the same answer. Or we're just going to go ahead and divide by 8. Since it's already out in front, it's factored out already, we don't have to distribute it through, and it will just cancel. 24 divided by 8 is 3 equals y plus 5. Subtract 5. Y equals negative 2. Now, this one in particular we do need to check because we can't take the log of a negative. So we're going to go back to our problem where our y is, negative 2 plus 5. That equals 3. And we can take the log of 3. 3 is a positive number. So this is the answer. Okay, be sure that you check to see if it works. Okay, that's our second example. Let's go on to our third example. Our third example is 4 log base 2 of x minus log base 2 of 5 equals log base 2 of 125. First thing we want to check for is that power property. Well, in this case, we have a 4 out in front. That 4 is going to move up and become the exponent on our x, because that's what the power property says we can do. So it's going to be rewritten as log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Now we want to move on to the second step, see if it's going to be the product or the quotient, or a combination of both. Minus sign, quotient property, which means we're going to make a fraction. Log base 2 of x to the 4th over 5 equals log base 2 of 125. Now both sides have one log, they have the same base, cancel each other out. So x to the 4th over 5 equals 125. We're going to get rid of our fraction, so we're going to multiply both sides by 5. Cancels that out. We have x to the 4th equals 125 times 5 is 625. Now at this point, we're going to take the 4th root of both sides. So x equals, when we take the 4th root of something, it's an even exponent, an even index. We're really going to have a plus minus on it, so it's plus or minus 5, and you need to make sure you go back and check. Because when we go back to the original problem, right here, log base 2 of x, I can't take the log of a negative. So if I have log base 2 of negative 5 is not going to work. So the only answer we end up with is positive 5 to the problem, because when we plug 5 in, we do get the log of a positive answer. So that one does work. That's the importance of checking our answers, because in that case we got 2, but only one of them is actually going to work. One more example here, and this one's a little different. If we're looking at this problem, notice that our logs are only on the left-hand side. We have log base 6 of parentheses a squared plus 2 plus log base 6 of 2 equals regular old 2. There's no log here. Alright? This tells us we're not going to use the equality property. If there's not logs on both sides, there's no way to get logs on both sides. So we can't use the equality property. What we're going to do is we'll end up rewriting it using the curl. Okay, we talked about that in the video last time. We start at the base, go to the answer, and come back to the middle. Let's combine stuff though. Let's see if we can use the power, product, and quotient property first. Okay, there's no numbers out in front on either of the logs, so we can't use that. There is a plus sign though, which tells us it's going to be the product property. So we have log base 6 of 2 times a squared plus 2 equals regular 2. I'm going to go ahead and distribute that through. So it's log base 6 of 2a squared plus 4 equals 2. Now we're going to use that curl. So we started at 6. 6 to the second power equals 2a squared plus 4. 6 squared is really 36, so I am going to subtract 4 from both sides, and that makes it 36 minus 4, which is 32, equals 2a squared. Divide both sides by 2. 32 divided by 2 is 16. Those cancel. So a squared equals 16. Square root both sides. Remember, when you square root, you need a plus minus. So a equals plus or minus square root of 16 is 4. Now we need to check our answers, because we got 2 here, and one of them is negative. When we go back to the original problem, it would be 4 squared plus 2. 4 squared is 16 plus 2 would be 18. That one works. When we plug in negative 4 squared is positive 16 plus 2 is 18. So that one works. So in this case, we have 2 answers, because both of them work in the problem. And again, that's the importance of checking your answer. Now, one last thing I want to talk about here is a common mistake, and I've already talked about it once. If we have a problem like log base 8 of 7a plus log base 8 of 10 equals log base 8 of 5a minus 2, what happens a lot is people just cancel these out. And this is a no, you can't do that. You must have one log on both sides. And that's really important in order to use that equality property. There's not here. Okay? Okay? There's 2 logs on the left and 1 log on the right. It's not going to work. You can combine them and then cancel, but at this point, you can't do that because you must have 1 log on both sides. Okay, those are your notes for section 10.3 on properties of logs. If you have any questions, make sure you bring them to class next time. Otherwise, you are finished, and make sure you bring your notes to class.